Hello, geometry. Welcome to an Algebra 1 review. This I'm doing this now. It's not technically part of Unit 9, but we use radicals a lot in Unit 9, and you're going to need how to deal with them. So we're going to take a little time to review everything from the radicals unit in Algebra 1. So the first one was just simplifying radicals. The way I taught it is the factor tree. So if you had me for this, you'd recognize it. I know a lot of other teachers teach it this way as well. So you've probably seen it before, but if you haven't, let me know and I can show you another way. Um, so I'm breaking this down into its prime factors. So any two numbers that multiply to 54, except for one, you can't use one. So 9 and 6 are either one of those prime? No, so I'm going to keep going. 9 breaks down into 3 and 3. Those are both prime, so I circle them. That means I'm done with that part. 6 breaks down into 3 and 2. Both of those are prime as well. And what you're looking for is pairs of the same number. I will take the time on this first one only to explain why. So I'm going to take all those circled numbers and put them inside the radical. So 3 times 3 times 3 times 3, or sorry, times 2. And now I'm going to split it up. I'm going to put the 2 3s here. And then I'm going to put another 3 and the 2 together, the unpaired things together. Now, why do I do that? Well, 3 times 3 is 9, but I could also write it as 3 squared. And what happens with the radical and the squared? They cancel, and I'm left with a 3 on the outside. The unpaired stuff I can't write as something squared, so it stays under the radical, and you multiply those back together, you get 3 radical 6, which is the simplest radical form of square root of 54. Okay. Next one I'll do much quicker. 360 is 36 and 10. 36 is 6 and 6. 10 is 5 and 2. Those are both prime. 6 is not. 3 and 2. 3 and 2. And now I'm looking for pairs. I'm going to cross out my pairs. So I got a pair of 3s. I've got a pair of 2s. So that makes a 3 on the outside and a 2 on the outside. And I multiply those together. 5 and 2 are unpaired. They go back under the radical. 5 times 2 is 10. So my final answer here is 6 radical 10. Okay. Moving down. Let's see here. Simplifying with multiplication. Sorry. I'm going to first multiply my stuff together. All right, so I'm going to multiply the outside stuff with the outside stuff. So 8 times 2 is 16. Inside stuff, 6 times 3 is 18. And now I'm going to simplify the square root of 18. Now, what do I do with the 16? Well, I just have to multiply 16 by whatever comes out of the radical. So let's figure out what comes out of the radical. It's 9 and 2. 2 is prime. 9 breaks down into 3 and 3. Both of those are prime, so it's a pair of 3s. It's 3 on the outside, radical 2. That goes here. And now I can have 16 times 3, and my final answer here is 48 radical 2. One that you see a lot is number 4, where you will have to square something with a radical. So 5 radical 7 squared is 5 radical 7 times 5 radical 7. If you just go straight to your calculator and type that in, you're probably going to get it wrong. If you want to try it, go ahead. A lot of people will get 35 there, which is incorrect. And I can show you why. If you're interested, let me know. But anyway, 5 times 5 is 25. And then radical 7 times radical 7 is radical 49. Well, the square root of 49 is just a good number. It's 7. 25 times 7 is 175. No radical anymore. That one's done. All right. Simplifying with fractions. This showed up in the trig unit a little bit, not a ton, but it will show up more in this unit. So you got to make sure you understand how to do this. We can't have a radical in the bottom. That's the key thing here. So right now I could split this up into the square root of 8 over the square root of 3. I could break down 8, but it doesn't really matter. right now because the square root of 3 is not going to be broken down and there's a radical in the bottom. So what I'm going to do is I'm going to get rid of that radical as fast as I can. I'm going to multiply the bottom by the square root of 3. Why? Well, the square root of 3 times the square root of 3 is the square root of 3 squared, which cancels my radical. Leaves me with just 3 on the bottom. Well, I can do that as long as I do the same thing to the top. So back to this step here, I'm going to multiply the top by radical 3 as well. Now, the radical is not going to cancel on this one because 8 times 3 is not 3 squared. 8 times 3 is 24. And now I just need to break down the square root of 24 to simplify the top. It's okay to have a radical in the top. You just can't have one in the bottom. 6 is 3 and 2. I've got a pair of 2's. Left over 3 and 2, so 2 radical 6. So my final answer here is 2 radical 6 over 3. You want to check, make sure you can't reduce because you brought a number out, 2. It could reduce with the 3. In this case, it doesn't, so you're done. All right, next one. 10 over radical 2. You cannot reduce that. 10's outside the radical, 2 is inside the radical. Can't do anything with that right now. I'm going to get rid of the radical on the bottom. Multiply by radical 2. That makes 2 squared on the bottom, which cancels the radical and leaves me with just 2. Got to do the same thing to the top then. Now, a lot of people think, oh, that's square root of 20. No, it's not because 10 is outside the radical, 2 is inside. So the only thing you can do here is 10 radical 2. Now I can reduce the 10 and the 2 because they're both outside the radical. So 10 divided by 2 is 5 on top, radical 2. No fraction anymore because the bottom is 1. All right, almost done. Last thing here is adding and subtracting. Now, the first one's pretty simple. You can only add and subtract if the number under the radical is the same. So I could put the radical 6 with the radical 6, and I can put the 2 radical 3 with the 5 radical 3. So let's do that. All you do is put the numbers in front together. So 3 radical 6 minus radical 6, or minus 1 radical 6, is 2 radical 6. Notice the radical does not change. So it's 3 radical 6 minus 1 radical 6. It's like 3x minus 1x. It's just 2x, 2 radical 6. And then 2 radical 3 plus 5 radical 3 is 7 radical 3. Can't put that together any more than that. There's my answer. Number 8. Looks like you're done because the numbers under the radical are not the same. However, the numbers under the radical can be simplified, and we need to do that. So square root of 60, I'm going to break that down. And the square root of 135, I'm going to break that down. So 60 is 30 and 2, 15 and 2, and that would be 3 and 5. Pair of 2's, so a 2 on the outside and a 15 on the inside. So when I multiply that all together, I get 10 radical 15. Now let's break down the 135. No 5 goes into it. Grab my calculator here. That's 27. 27 breaks down into 9 and 3. And then 9 breaks down into 3 and 3. So I got a pair of 3's with a leftover 3 and 5. So that's 3 radical 15. Multiply those together, I get negative 6 radical 15. Now the numbers under the radical are the same, and I can put those together to make 4 radical 15. Hopefully this is all review for you. But if it wasn't, hopefully it helped. We are going to be using this a lot, starting with lesson 1.